Well, the good news is this is the last lab. The bad news is those 3 graphs. Today's lab has 3 parts. It's Hooke's law, simple harmonic motion of a spring, and simple harmonic motion of a pendulum. For the first part is Hooke's law. What we're going to do is we have a spring hanging here, just at rest. And we have a little guide to show us how far it's stretched. Right now with no mass, it reads 0. This is in centimeters. What I'm going to do is I'm going to apply mass. By applying mass, I apply a force on the spring. The mass I added was 5 grams. You can convert that to kilograms yourself. The force would then just be mg. What we're going to do is we're going to apply various amounts of mass, adding more, and as we add more mass, we're applying more force. As we apply more force, the spring stretches more. We're going to record how far it stretches in meters, and then you're going to plot F versus X. I'll get all the values for force and X. Sorry, I'll get all the values for X. You'll get force yourself. Make that plot, and when you graph it, the slope of the graph should be the spring constant of the spring. For part B, what I did is I took this guy, moved him upside down, and I'm going to do simple harmonic motion. What I'm going to do is I'm going to add some mass, and I'm going to set it oscillating. Let's zoom out a tiny bit. And so, and for each amount of mass, that was a really wobbly one. For each amount of mass, I'm going to use this to get the period. It's a little hard. I'm going to get the period by recording how long it takes it to go up and down 10 times and divide that by 10. I'll do the math for you. Once you get all the values of t for each value of m, what we're going to do is we're going to square t, and we're going to make another graph. In this case, we will be graphing t squared versus m. And from that slope, we'll solve for k. The equations will be in the lab. I'm going to do this for a series of masses, as I said. The last part is the pendulum. So here's my pendulum. You know what? I'm going to move further. What I'm going to do is I have this pendulum hooked up to a long string, and I'm going to swing it. Once I swing it, I'm going to measure the period, just how long it takes to go from right here, how long it takes it to go right to there again. I'm actually going to time how long it takes to go there and back 10 times, and then divide by 10 to get the value of the period. I'm then going to go and change the length by taking this and kind of wrapping it around the pole and shortening the length. And I'm going to measure the length. For each length, I will measure the period. And then you will, I get all the periods, you're going to square the periods, and you're going to graph t squared versus L. Using that, you're going to solve for the acceleration of gravity, g. Sorry, these labs kind of suck online. Doing my best.